Hi guys, I'm Dmitry, and I work in Plarium, and I went here from Krasnodar right now. So I will talk about the Kaggle. It's a competition that was hosted in Kaggle. It's iMet collection. Let me make a brief introduction to that. Actually, the New York City has a very splendid Metropolitan Museum of Art, and this museum has the tremendous amount of objects. It's a diverse collection of history objects, which counts like 1.5 million of them and counting. And they have a lot of people who are experts in the history of art or history of objects. They can create annotations and describe all that stuff in a historical perspective. But actually they can be wrong in describing fine and grained attributes. That was the idea why this museum came up with an idea to create the competition in Kaggle, actually. That's why it's quite easy understandable that task is multi-class classification, and type was not so very common, actually. It was a kernel-only inference, so you can free to train all your models on offline and inference everything actually on a kernel. So you can load all your ways and do all predictions inside the kernel. More, it has a stage 2 with a much bigger data, actually it's 5 times approximately. My position was 18th from approximately 500, and it's top 5. So let's briefly describe the data. The data is not very large in competition with the open images, for instance, but it's 22 gigabytes of the data, about 100 images like that. You can see them here, and labels. It's quite interesting actually, because it was 2 types of labels. It's cultural labels and the tags. You can see that's bigger words actually from that kernel, bottom of the slide, and here you can see a basic grip of what each cultural or tag means. Actually, cultural means connection to the nation, country, maybe some specific time, and tags connection to the depiction of the object, like it's birds, woman, person, portrait, and events. Evaluation of that competition was a mean F2 score, because lots of images haven't only one label. Actually, it's what's the problem. Here they had like 3, maybe 5 or 7 labels each. That's why. What's the start actually here? Usually for that type of task, we can just open the transfer learning in some cases, and if you open any image classification or image connected competition on Kaggle nowadays, you can see that almost public kernels connected to a FastEye or maybe PyTorch. This competition, Konstantin Lopukin creates a nice kernel with an example of how he create a script from several scripts in a Python. So you can't use a notebook here, you can use a script, and it would be connected to all your code. Actually, you don't need to copy paste all your files in one script. It's quite easy, and he creates a template. You can go to his GitHub and see his code. It's very valuable actually. So first approach was transfer learning with a REST-net. I checked all REST-nets and dense nets for that to understand the hypothesis if we can create a much deeper model, and it would be better or not, because usually in some tasks of this type, we have some situations like REST-net 34 can be much better than REST-net, bigger REST-net actually. But in this competition, we have a situation then deeper is better actually in most cases. That's why the first baseline was on REST-net, and it's approximate training actually here. Validation schema was pretty normal for that competition, but it's not a stratification. In usual term, it's a multi-label iterative classification. In case of that image has lots of labels inside. We can use ordinary certification because we want to see lots of images with labels inside, actually, with the equal labels. But if we use multi-label iterative certifications, some like a greedy algorithm, we can split off all of our data in a pretty nice folds without problems. So we can see an example here because we have lots of items. For instance, a tuple with 0, 0, and 5 and 5, and 2, 4. So this algorithm can split them equally in folds. Well, almost everybody in a top 50, I think, use this scheme actually. Moreover, it was a 5-fold, and in the end of the competition, I switched to a 6-fold for some models actually. Probably it's better, but as I said, it was a kernel inference competition, and they had a limit for the time, actually 9 hours. That's why you can stack lots of models and make lots of TTA and see the result. You have only 9 hours for that. Well, so the first approach was the ResNet 152 with 2 augmentations, random resize crop and random horizontal clip, 5 folds, and TTA like 2 or maybe 4. After the training, it gives like top 10, top 50. In that time, actually I started quite late, on the middle of the competition. That's why it was like 3 weeks before the end for the stage 1. After that, I came up with an idea that I need to check current state of the art, and I can recommend the nice site, Papers with Code, because it gives you all current sort for almost every task which you need. If it's classification, multi-label classification, some segmentation, detection, doesn't matter. It has lots of things with the papers, code is available. And I think that I thought in that time that the nice try I could give to the CNET and ResNext. Actually, FSNet, as you can see, was published like several days before the end of the competition with the Keras and TensorFlow code. That's why it was an option in the middle of the competition. In SNet, actually, I don't need them because I thought that I won't have time in the future in kernel for the inference so much folds and models. So I checked on the last 2 models. After that, after the training, I finished up approximately in top 25, and I had a week of time. I checked lots of things like augmentations. Some of them works, some of them not, or something like cut out. It was pretty strange, but it doesn't give some nice results. It's actually dropped the result quite significantly. LR training. Well, I choose that my LR learning rate schedule was quite nice because I checked lots of pictures and training validation things, and it was quite tricky thing. I don't know why cosine learning rate doesn't work for me. Here I checked that. Image size is even more, like 320 pixels was pretty standard for every participant in the top, as I knew after the finish of the competition. And thresholds was tricky because if you use a single model, single fold, usually 0.9 or 0.95 was nice then, standard 0.10. But at the end of the competition, I saw that my blends of the all folds works better than with the last threshold actually. After the results, and mix all those things, I saw that I have much time in the kernel actually, because inference was like 3 minutes for the CNET, and the series next to like a minute and a half. Moreover, I would like to say that we have in stage 2 data set 2 times bigger. That's why CNET inference for the one fold will take like 20 minutes. And I decided to make a special trick for that because we don't know exactly how much time. 5 times, 5.5 times bigger data set. It's pretty basic trick, and probably not everybody uses it in competitions, but it gives me actually 5 places in a leaderboard up to the stage 2. I made it. I measured time for my one fold actually, and calculate the TTA amount for the next folds. So I create 2 kernels. One kernel is approximately TTA 4 for every fold, and I knew that it will run like 8 hours and a half, maybe 8 hours. A bit less, depends on the data set. But these will last approximately 9 hours, almost every time. And it gives me a little boost, a slightly boost. So after this scheme, I finished in approximately in top 20 before the end of the competition, and we wait for the stage 2. So it's my decision. Here, I would like to briefly explain and describe the solution of the winner, Konstantin Gavrilchik. It's a much more masterpiece of work, not so simple pipelines like I did. He has approximately the same models in his pipeline, and CV was the same 5-fold multi-label iterative stratification. That augmentations was more sophisticated. He used horizontal flip, random brightness and contrast. I used color jitter, but he used it not for all images, for time to time, one of all. For one, sometimes he uses random brightness for the image with some probability. Sometimes shift scale rotate, and depends actually on his code actually. Data preprocessing, he doesn't use a random resized crop because he noticed that lots of images have a lot of completely different sizes. And if he uses random resized crop, time to time he noticed the situation then a crop from the picture doesn't contain the whole object or maybe object at all. That's why the model will be a bit tricked about that and doesn't know what to do actually with this piece of image. So he used crop if needed, if the image too big, and resize after that. Layer scheduler was pretty the same because he, as usual, as everybody noticed that it's very valuable and increased accuracy level. He had several stages. First of all, it's training. He used accumulation of batches. I checked some accumulations up to 100. It doesn't give me any improvement, so I dropped that. But probably it works for him. At stage 2, he filtered predictions. He just dropped images from the train with a very high error between out-of-fold predictions and labels, and add a very small amount of negative mining. Actually, he reuses some samples for each path with which was quite hard for the models. After the H stage, he completely retrained from the 0 all models. That's why it takes quite a lot of time. And for the stage 3 in this competition, he added to the train some images with very confident predictions. It boosted his scores, and he created a bit more training data set for that. In stage 4, he noticed that cultural and tags labels quite different actually, because tags are less noisy than cultural, and after training some of his models doesn't improve in a cultural accuracy. He changed the F2 score for the 2 F2 scores, one for tags, one and another for cultural. And after this piece of information in his mind, he came up with an idea to retrain all models after the complete train, but train them only for the tags. So basically he trained model with the tags and culture labels, and afterwards he started to train this certain model for the tags only. Moreover, he had some information from an ImageNet class, because lots of information here, as you can see, tags here, connected to the ImageNet dataset. But ImageNet has much more weights. That's why he blended all his decisions, all his predictions with ImageNet. And after this stage, he added the second level model. It was quite an interesting decision, because he created a huge amount of data sets, actually 1,000 rows and counting for each image, and tried to create a binary classification task actually here. He extracted a huge amount of data from his trained models, like probability of each model, some division of that probabilities for each image, some statistics from channels of the image, max sides, binary flags, and lots of them, and trained on all that information LightGBM. He noticed that he hadn't lots of time for the LightGBM kernel, but he used it in some case actually. And hint from him that he uses different thresholds for tags and cultures, not 0 and 10 for everything. So it was his nice work. It takes lots of strenuous efforts, and some minor hints were quite basic, but it's much better to spend all your time, efforts, and GPU time only for one completion in a time in a row, because it's much better actually. Search for the previous solutions for the same task. It's a very nice thing. I don't think that I could describe it, because it's basic and understandable. You can see that the pipelines of the other guys and the other preceding competitions or previous works and papers can give you insights for this information, insights for how you can proceed in a high place or higher understanding of the problem. And more, you can check the papers in current SOTA right now in a Slack of ODS, maybe in RCIF, or again in a point 2 actually. And don't use notebooks widely. I don't say that you don't need notebooks for the EDA, for some prototyping, but the whole pipeline and using, especially in a kernel applications, it's much better to create a nice pipeline with the code, PyCharm, for instance, or Visual Studio Code, it depends, and code it and reuse it. With notebooks, it's a bit tricky. Thanks. Questions? Yes.
I have one question about dropping a sample with big errors on a solution of winner. You said that he dropped some hard sample, and after that you said that he do hard mining. How it's combined with each other?
Well, probably he removed from the train some images that wasn't good for the training, but he checked. Well, he can add images with a very hard tags or labels for the training, but if you see that this image doesn't improve the model, or model doesn't predict them well, even if they see it often or more often than if it's a test train, data set to train, he just removed them, probably that one. I actually, yes, I have hesitations like you, but it seems to me that it was in that case.
Hey, thank you.